So in the last video, we started building this 16-byte memory, which is able to store 16 bytes. We've got the 4 address lines here to select which of the 16 bytes we're reading or writing to. We've got 8 data lines for inputting the data that we're going to write into the memory location that's selected with the address line. And we've got our 8 outputs that are buffered through this 8-bit tri-state buffer, so we can output to a bus. In this video, what I want to do is start to connect the address lines here to our address register. And since the memory address is just 4 bits, we can use the 74LS173 that we've used in the past, which is a 4-bit register. So I'm going to start by just getting another breadboard and connecting it up here like that. I'm also going to remove this top one and connect the clock module that we built in some of the earlier videos. And it's not that the clock module is directly related to the memory at all, but just the final layout of the computer, we're going to have the clock module just above the RAM. And so now that gives us room in here that we can go ahead and put together our memory address register, which is going to connect into our memory address lines here. So I'm going to just get these out of the way for now. Just move them all down here. Just give ourselves a little bit more room. So the memory address register, we're going to use the 74LS173 that we've used many times before for registers. And I'll hook that up over here. That's going to be connected to the bus because at various points we're going to have memory address appear on the bus, and we'll want to bring that in and store that in the memory address register, which will then be connected to our memory to tell it what address to address. And then once that address is set there, then we'll either output contents from the bus, or we might input a new value from the bus into the memory. But while we're inputting or outputting from the memory, we need to store the address to which we're storing or reading from in this address register. So we could just, it seems like it'd be simple enough to just take these address lines and hook them up to this register, and then whatever's stored in that register will be the address that we're pointing to in our memory here. But we don't want to just do that. We also want to be able to program the computer. And when we program the computer, we basically want to just switch the memory into a totally different mode where we're able to set the address and set the data by hand with like dip switches like this. And so we want to have some switches here that allow us to set what address we're pointing to. And then we'll have another set of dip switches where we can set the data that we want to write into that memory location, so we can program the computer by hand. And then we want to be able to switch out of programming mode and use this register. So we basically want these address lines to either be hooked up to the register, or so that the memory can be addressed by data coming in from the bus, or an address coming in from the bus. Or we want to be able to set the address with these switches, and we want to be able to switch between those two things. You can imagine we've got 4 bits over here of address, and we've got 4 bits over here of address set on these switches. How do we switch between those? Well, this is a fairly straightforward circuit that we can kind of reason through, that allows us to select between 2 different values. So, for example, and this is just 1 bit. So, for example, the first bit of our address that's stored in our register might be A, and the first bit of our address on these switches might be B. And then we can select which of those we want to use using the select signal. And you can kind of see how that works, where if select is high, then this input to the AND gate will be a 1. Which means that if this other input to the AND gate is a 1, then the output's a 1. If this input's a 0, then the output's a 0. So if select is a 1, then this A signal is just basically going to pass through the AND gate. And because this is inverted, this AND gate will definitely always be a 0, because we'll have a 0 coming in here. And then the OR gate will just be whatever is coming in A. If select goes low, then this AND gate is basically always going to be off, because we'll have a 0 coming in here. And we'll have a 1 coming in here, so this AND gate will pass through the B, and then of course the OR gate, it'll be a 0 or whatever B is, and so the output will just be whatever B is. And so by setting the select high or low, we're selecting whether we want A or B to appear on this output. Conveniently, there is a chip that does exactly this. It's the 74LS157, which is a quad 2-line to 1-line data selector. So we're selecting between, from 2 lines to 1 line, which is kind of what we just described. And you can see here on the data sheet, it has essentially 4 copies of that circuit. So you can see the 2 AND gates and the OR gate, which is what we were just looking at here, the 2 AND gates and the OR gate, and then the inverter down here for select that's inverting depending on whether we're selecting the 4 A's or the 4 B's. So there's a single select that selects between all 4 A's or all 4 B's. This also, you can see there's a third input on all of these AND gates that goes to this strobe, which is basically just kind of a master enable. So as long as this strobe is low, then this third input to all these AND gates will be a 1, and essentially that enables the whole chip. So we'll just tie this low for our purposes, and then it'll essentially just behave like this circuit that I just showed you. And so if you look at the pinout for the 74LS157, you can see, of course, we have our select input, selecting A or B, and then you can see there's an A, B, and an output, A, B, and an output, A, B, and an output, A, B, and an output. So it's basically 4 of these that are all tied to a single select. And then, of course, we have our ground and our power, and then this strobe line, which I said we'll tie low just to enable the thing. So this 74LS157 will basically allow us to select, and toggle between, do we want to use the switches to set the address of our memory, or do we want to use the memory register to set the address of our memory? So I'll go ahead and add the 74LS157 here. We can connect the power and ground here, so connect the power for that guy. And then remember this pin 15 is this strobe, which we just want to set low to enable this chip. So we'll just set that low. And then while we're here, I can also connect the power for our address register, the 74LS173. So power and ground. I'm going to pull these LEDs out of here. We're just using those for testing. So we got that powered up. And then the 74LS173, this is what it looks like. And remember, again, it's got 4 D flip-flops that are storing our 4 bits in our register. And we have our output control, which if pins 1 and 2 are low, then our output is enabled. And we always want that to be the case. So we'll go ahead and tie pins 1 and 2 low so that our output is always enabled. And then we also have our data enable, pins 9 and 10, and that controls whether the input, which is going to come from the bus, is being clocked in on the clock pulse. So this is going to be a control signal to tell it to store whatever's on the bus in this register. So that's pins 9 and 10. So I'll hook pins 9 and 10 together, and then that's just a control signal that we'll need to set either high or low to control whether we're storing a new value in here. And then pin 7 is our clock, so we can hook that up to our clock up here, which we've now got nearby. So now these 4 pins here, 11, 12, 13, and 14, are the inputs for our register, and so those will be connected off to our bus at some point. And then our outputs are pins 3, 4, 5, and 6. So we can connect the outputs to one of the 2 inputs of the 74LS157, right? Because it has these A and B inputs for the 4 bits that it has. So let's go ahead and connect the 4 bits of the register to the 4 B inputs, and then we'll connect our dip switches to the A inputs. Okay, so now the outputs of our memory address register are going into one of the inputs of our 74LS157 selector. So we'll be able to select either this or the dip switches. So now to hook up the dip switches to the other input of the 74LS157, what I want to do is take advantage of the way that the inputs on these chips work, which is for most of these TTL chips that we're using, the inputs are tied high. There's a resistor inside these chips that connects the input to plus 5 volts. So if we don't connect these switches to here at all, then the A inputs on this will all be 1s by default. And if we then connect some of the inputs to ground, then those inputs that we connect to ground will be 0s, and the rest of the inputs that aren't connected will be 1s. So what we can do is we can connect this to these switches, and then the switches we can use to selectively connect a pin to ground or not. So for example, for the first bit here, pin 2 is the A input, pin 3 is the B input, and pin 4 is the output. So for the B input, we already have that connected up to our register. For the A input, I can connect that to the first switch here on our dip switch. And if it's off like this, then it's not connected, and this is going to be a 1. If I turn it on, then it will complete the circuit over to this side. And if I connect that side to ground, then turning this on will connect this to 0. And so on is 0, and then off will be a 1 because it's not connected. And I can do the same thing for the second bit. Just connect the second switch to the A input of our second selector here, and connect the other side of this switch again to ground. And so if the switch is off, then this input defaults to a 1. If the switch is on, then it connects it to ground, and it takes this down to a 0. Same thing for the third bit. In this case, the input is up here on the top side of the chip, so I can just kind of run through the switch the other way and connect the ground down here. And so then again, if the switch is on, then it connects the ground to that pin. If it's off, then it doesn't, and so then it defaults to a 1. And then finally, for the last bit, I can do the same thing and connect to ground here. One thing that's a little bit confusing about this is that when the switches are in the down position here, when they're off, then basically we're inputting all 1s. And if they're up like this, they're all up, they're all on, that means that we are connecting all of these inputs to ground, and so we're inputting all 0s. So it might be a little bit confusing, because usually you would think down would be 0 and up would be a 1. Fortunately, there's a pretty easy solution to that, which is turn the switch around so that when the switch is down, it's on, and when it's up, it's off. So now we have the 74LS157, which can select between either the dip switch input or the address register input, but we need to have some way of telling it which one we want. So I'm going to add a switch here that we can toggle between the dip switches and the address register. And this is a double throw switch, so we can connect the center pin here to ground, and then depending on which position the switch is in, whether we have it pushed in or pushed out, it'll connect that ground to either the left pin or the right pin. And so something I want to do just to make this a little bit, I don't know, maybe a little nicer to use, is have some indicator LEDs to tell us which position the switch is in. I mean, you can look at the switch and see, but I like having these indicators so we can tell which mode the computer is in, because we definitely want to be able to tell pretty easily whether the computer is in programming mode, which will be the red LED on, or in run mode, which means the green LED is on. So what I'll do is connect the switch up here to both of these LEDs. So one side of the switch to the red LED, and the other side of the switch to the green LED. And then the other side of the LED will hook up to our 5 volts through these current limiting resistors. And we need current limiting resistors here, because we're connecting, whichever position the switch is in, we're going to be connecting directly from 5 volts through the LED to ground. And so without a current limiting resistor, we'll be pushing tons of current through the LED and we'll burn it out. We don't need those in these cases because these chips have resistors, essentially resistors on the collector side of the outputs. So it's already going to limit the current that it can drive. But in this case, we do need them. And so if I go ahead and connect up some power here, just to kind of show you what we've got so far, let me just connect my power all the way through here. and then hook up power to this whole board. Of course, we've got our clock going and something in our memory, but what you'll see now is, depending on how we toggle the switch, it selects either green or red, basically. But the other thing that happens is, what this is really doing is selecting which of these two things is grounded. And so in this case, the red LED here is grounded, and in this case, the green LED is grounded to complete the circuit from the 5 volts through the resistor here. And so what we can do is we can connect the red LED side here to pin 1 of the 74LS157, and pin 1 is the select pin, which selects which of the two inputs we're going to use. And so if we're on the red LED, essentially pin 1 then goes low, and we're, let's see, which one are we selecting? So if select is low, then it looks like we're selecting the A input. So if we're on the red LED, so if pin 1 is low, then we're selecting A, which is our dip switches. So red LED on means that we're using our dip switches, which means we're in programming mode, because we're using our dip switches to program the computer. And then if we switch modes here, then this is no longer connected, and so pin 1 will default to being high, in which case it's going to use input 2, or B rather, input B, which is our register over here, and so we're going to be using the address register. Of course, this will make a lot more sense if we hook up the outputs of the 74LS157 so we can actually see what's going on. Okay, so there's our outputs, and now if we start here in run mode, it's going to, our output here will be whatever we've got in the register, which appears to be all zeros, either that or it's not working right. And then if we switch to program mode, then the output here should reflect whatever our dip switches show. So 0011 makes sense. If we turn those off, it's all zeros. And you can see it's just, whatever we put in our dip switches here is what we're getting out here. And then if we switch back to run mode, you see we get all zeros, and that's presumably what is stored in this register. And we can try to get something else in this register. I think if we set the input signal low here, we should see, well, I would expect it to read in all ones because none of these inputs are connected. Oh, but our reset signal is also not connected. So this is constantly being reset. So pin 15 is the clear signal. So we want to keep that high. Actually, I think we want to keep it low, right? Okay, that might make more sense. Yeah, so we want our clear signal to be low so that we're not constantly clearing this, right? Because it would be defaulting to be high. And then if we bring our data enable low, then it should read in whatever's on the bus here, which is going to default to all ones. But we could try hooking a couple of these bits. Let's just hook up 2 bits here to ground. And then set our input signal low. Okay, and then on the next clock cycle, it read that in. And so that's what's in this register now. Okay, so it looks like we can input a value into this register, and it shows up here if we're in run mode. And then if we switch over to program mode, then we get whatever we set on these switches. So now all we need to do is just hook up our outputs here, which right now are just going to these LEDs, and actually hook them into the memory address input of our actual memory. Okay, so now I've got our outputs hooked up to our address line inputs of our memory. So let's go ahead and power this back up again. And so we can see it came up, so we're in program mode, so the 0101 that we have in our dip switches is what we're seeing here. And we're seeing something random in memory, so we don't really know what that is, but if we change the address, we should see different things. And there we go. So if we go to address 0, we see that. If we go to address 1, we see something different. Address 2, something different. Address 3, something different. So there's something different in each address. I mean, I guess we don't know for sure if we're addressing it right, but I mean, it seems reasonable that if we're going to different addresses here, we're getting different things. And if we switch out of program mode to run mode, we see this goes back to 0, and we see that we get this whatever random thing was in address 0. So it looks like we're able to switch between run and program mode. And in run mode, we're going to be using whatever is in our memory address register. And actually, we can try to put that value back in here if we switch this over there. Yep, and we can see when that changes, we got to a different address here. If we go back to program mode, we have the same address set here, so we see the same thing here. If we change address, yeah, it looks like we're able now to change our address either in programming mode with our dip switches, or when we go to run mode, it's looking at whatever is in our memory address register here, which we can set by putting some value on these 4 pins here, which will be connected to the bus, and then we'll have a control signal to read from the bus. So great, now in the next video, we will try to do the same thing for our data lines. Because again, when we're in program mode, we want to be able to use the dip switch to set our 8 data lines. So we can set an address, we can set data, and then we can write that data into the memory, and then we can switch back to run mode, and instead of using the dip switches, it'll use whatever's on the bus. So in the next video, we'll basically do the same thing that we just did, but for data lines, and that should wrap up everything we need for our memory section.